For as long as we can remember, humans have been utilizing both renewable and non-renewable sources to fulfill their energy requirements. Certainly they have had their disadvantages, and now, in the form of climate change, we are facing the biggest existential crisis in human history. However, this will not be a problem anymore because scientists have finally found a way to produce massive amounts of sustainable energy like nature has been doing for billions of years. Yeah, you got it right. Scientists have finally been successful in creating a nuclear fusion reaction on Earth. Join us as we get deeper into the exciting and game-changing news. How did the scientists make it possible? When will we get to experience it? And what makes it groundbreaking? The sun is one of the most important sources of energies found on Earth. Hundreds of years ago, a civilization in today's Mexico, known as the Aztecs, believed that the blood of human sacrifice was the reason for the sustainability of the sun's power. However, today, we know that it's powered by the most sought-after resource known as the nuclear fusion reaction. Scientists have been trying to seek this source of energy for around a century now, because they know if nuclear fusion can be duplicated on Earth, it has the potential to supply nearly endless, clean, safe, and economical energy to meet the world's energy demand. And now, they're closer than ever. On February 9, 2022, scientists working on a giant donut-shaped machine known as a tokamak in the English village of Culham near Oxford announced that they had generated and sustained nuclear fusion. Scientists at the Joint European Torus, or JET, tokamak were able to generate a record-breaking 59 megajoules of sustained energy fusion over 5 seconds on December 21st of last year. 5 seconds is the maximum the machine can sustain power before its magnets overheat. This was more than double the record from their previous experiments, performed in 1997. It was barely enough to power a house for a day, and the process consumed more energy than it produced. Nonetheless, it truly was a momentous occasion. It had demonstrated that nuclear fusion could be sustained on Earth. However, the question is, how do we make it last longer than 5 seconds? And why is it so painfully difficult to achieve? In our daily lives, there are many things that require a lot of energy. Nuclear power plays an important role in space exploration, as well as providing electricity to our homes. Nuclear energy is a form of energy released from the nucleus of an atom, and the process takes place in a nuclear power plant. Currently, there are 439 nuclear power plants around the world, with the US being on top with 96 power plants. It is a series of machines that can control nuclear fission, a process that has been in use for decades to produce electricity. Nuclear fusion is a reaction in which the nucleus of an atom splits into 2 or more smaller nuclei by the bombardment of neutrons. Some of the neutrons that are released then hit other atoms, causing them to fission too and to release more neutrons. This is called a chain reaction. The fuel used for nuclear fission is uranium. It's considered a non-renewable energy source, even though it is a common metal found in rocks worldwide. Nuclear power plants use a certain kind of uranium, referred to as U-235, for fuel, because its atoms are easily split apart. When the uranium-235 atom is bombarded with a neutron, it splits into 2 lighter nuclei, barium and krypton, with about 200 mega-electron volts of energy in the form of heat. The generated heat is removed from the reactor by a circulating fluid, typically water. This heat can then be used to generate steam, which drives turbines for electricity production. Now, there are some disadvantages to nuclear fission reactions that are really hard to ignore. The radiation emitted during the fission reaction is extremely harmful to humans and animals. A major environmental concern related to nuclear power is the creation of radioactive waste that puts living things in danger. Unlike fission, nuclear fusion is based on the idea that energy can be released by forcing atomic nuclei together rather than separating them. So, nuclear fusion is the process by which 2 light atomic nuclei combine to form a single, heavier one while releasing massive amounts of energy. Just like in fusion, the missing mass is what's converted into nuclear energy. In nuclear fusion, 2 nuclei of a lighter element, such as hydrogen, must overcome their natural electromagnetic repulsion and merge into a single, heavier nucleus. But generating enough power to smash atoms together until they stick is not easy, and it generally requires the extreme environment of a star's belly for that to happen. Unlike fission, fusion power would produce less nuclear waste and use relatively common light elements, like hydrogen. Scientists have long dreamed of making sustained fusion reactions here on Earth. However, creating and sustaining fusion is difficult because of such extreme conditions. But the news from England proved excellent for the project in France, where 35 countries came together to make nuclear fusion possible through the International Thermonuclear Experimental Reactor, the ITER for short. The reactor will be the largest device of its sort to be ever built, and it's going to be the flag bearer for nuclear fusion. Its main objective is to prove fusion can be utilized commercially. When it's operational, the experimental fusion plant will circulate plasma in its core that is 10 times hotter than the sun, surrounded by magnets as cold as interstellar space. ITER aims to use superconducting magnets to fuse hydrogen atoms and produce massive amounts of heat. The neutrons, which are able to escape the plasma, then hit a quote-unquote blanket lining the walls of the tokamak, and their kinetic energy transfers as heat. That heat can then be used to warm the water, to create steam, and to turn turbines to generate power. The experimental reactor will not use conventional hydrogen atoms, whose nuclei each consist of one proton. Instead, it will fuse deuterium with tritium. Deuterium is easily extracted from seawater, while tritium is rare but can be generated inside the fusion reactor. According to ITER, the supply of these fuels is abundant, enough for millions of years at current global energy usage. Recently, on May 11th, the ITER project achieved a major assembly milestone, as the first subsection of the ITER plasma chamber was successfully lifted out of tooling and lowered into the machine well. ITER's former Director General, who passed away on May 14th, expressed his enthusiasm for fusion energy. When the world's population was less than 1 billion, Bigot claimed that there were enough renewable resources to meet demand. He stated, "Not anymore, not since the Industrial Revolution and the following population explosion. So, we've embraced fossil fuels and did a lot of harm to the environment. And here we are now, 8 billion strong and in the middle of a dramatic climate crisis. There is no alternative but to wean ourselves off of our current main power source. And the best option seems to be the one the universe has been utilizing for billions of years." The amount of energy produced from fusion is very large, 4 times the amount as nuclear fission creates. Fusion energy will probably power most of the planet if it can actually be mastered. In fusion power, just 1 gram of fuel can produce the equivalent of 8 tons of oil. However, there are some problems. The difficult part, according to several ITER researchers, isn't creating fusion energy. Since the advent of the hydrogen bomb, humanity has been performing nuclear fusion reactions. The primary challenge is to keep it going. So it means that the purpose of ITER is not to use the energy for power, but to prove that it can sustain fusion energy for considerably longer than jet. If this project succeeds, commercial-scale devices will be able to generate fusion in the future. Another challenge for ITER is the hydrogen isotope tritium. Only 20 kilos are available in the world at the time, and demand is only 400 grams a year. Currently, a single gram is worth roughly $30,000. Demand for nuclear fusion will rise if it becomes widespread, offering yet another obstacle to world fusion scientists. But the problem doesn't end there. ITER appears to be a ready-to-go project from afar. It's evident that, from up close, it's still a long ways off. The project, which spans 39 construction sites, is extremely complicated. The shell of the tokamak has been completed, but essential components, like a massive magnet from Russia, they're still on the way. The tokamak will weigh 23,000 tons when it's finished. That is the weight of 3 Eiffel Towers put together. It'll be made up of 1 million parts, each of which will be broken down into 10 million smaller parts. Even the digital design is dispersed among multiple 3D computer files that use over 2 terabytes of storage space. ITER, which is managed by 7 primary members, China, the United States, the European Union, Russia, India, Japan, and South Korea, is also in danger because of the conflict with Ukraine. There are concerns over Russia's continued participation in ITER, as well as its possible exclusion. However, if the project proves successful, ITER scientists predict the fusion plants may start coming online as soon as 2040. with a 2-gigawatt fusion plant built to last 60 years or more. This will be a revolution and will end a crisis that we're facing today. What do you think about ITER? Share your views in the comment section below.